We know pi is equal to the circumference of a circle divided by its diameter.
The way Archimedes approximated pi was he inscribed a hexagon inside a circle and calculated the perimeter of the hexagon. So he knew the circumference of the circle would be slightly greater than the perimeter of the hexagon.
He also drew a hexagon outside the circle and calculated its perimeter, so he knew that the circumference of the circle would be slightly smaller than the perimeter of the circumscribed or outer hexagon.
Then he doubled the number of sides of each polygon and calculated the new perimeters to get an even better approximation of the circumference of the circle.
He continued to double the number of sides until he had inscribed and circumscribed a 96-sided polygon.
Once he had an approximation of the circumference, all he had to do was divide it by the diameter to get his approximation of pi.
Here we have a circle with a radius of 1 and therefore a diameter of 2.
Based on the formula c equals 2 pi r, this makes the circumference equal to 2 pi.
There is a regular hexagon inscribed inside the circle, which means that all the vertices of the hexagon touch the circle at one point.
The hexagon is divided into 6 equilateral triangles, so the side of each triangle is the same as the radius of the circle.
This makes the perimeter of the hexagon equal to 6, so we know that the circumference of the circle is slightly greater than 6. So we also know that pi is slightly greater than 6 divided by 2, which equals 3.
Now we're going to add a 12-sided polygon to the figure.
We'll also draw a line OC from the center of the circle to the midpoint of AB, dividing the triangle AOB in half and intersecting AB at a right angle.
Since OC divides the equilateral triangle in half, AC is half AB, which is equal to 0.5.
Also, triangle ACO is a right-angled triangle with a right angle at C, so by the Pythagorean theorem, we can get the equation OA squared minus AC squared equals OC squared.
AO is equal to 1 and AC is equal to 0.5.
So our equation becomes 1 squared minus 0.5 squared equals OC squared, or 1 minus 0.25 equals OC squared.
1 minus 0.25 equals 0.75, so we have the equation 0.75 equals OC squared, or OC is approximately equal to 0.866.
Line OD is another radius of the circle, therefore it's also equal to 1.
Therefore CD equals 1 minus 0.866, which is equal to 0.134.
Triangle ACD is also a right-angled triangle, with a right angle at C, which means by the Pythagorean theorem again, AC squared plus CD squared equals AD squared.
We know AC is 0.5, and we figured out that CD is 0.134, so the equation becomes 0.5 squared plus 0.134 squared equals AD squared.
Or 0.25 plus 0.017956 equals AD squared.
Or 0.267956 equals AD squared.
Therefore, AD equals approximately 0.518.
As you can see, AD is one side of a 12-sided polygon, which means that the perimeter of this polygon is 12 times AD, or 12 times 0.518, which is equal to 6.216.
The circumference of the circle is 2 pi, and the perimeter of the 12-sided polygon is 6.216. Therefore, 2 pi is slightly greater than 6.216, or pi is slightly greater than 6.216 over 2, which equals 3.108.
The next step of this method would be to divide triangle AOD in half, similar to how we divided AOB in half, and then repeat the method to find the perimeter of the new 24-sided polygon.
Archimedes continued this until he had a 96-sided polygon inscribed inside the circle.
Now we're going to add a polygon around the circle, which is called circumscribing.
You'll notice that the circumscribed polygon is just a scaled-up copy of the inscribed polygon. This means that if we can find a scale factor, we can multiply the perimeter of the inscribed polygon by the scale factor, and we get the perimeter of the circumscribed polygon.
When figuring out a scale factor, we call the original shape the object, and we call the scaled shape the image.
A scale factor is equal to a dimension of the image divided by the corresponding dimension of the object.
In this case, we will use the distance from the center of the polygon to the midpoint of one of its sides as our dimension.
For the inscribed polygon, this distance is OC, and for the circumscribed polygon, it's OD, which happens to be equal to the radius of the circle.
This means that the scale factor is OD over OC, which is approximately equal to 1 over 0.866.
We then take the scale factor and multiply it by the perimeter of the inscribed polygon, which was 6. This equation would be 6 times 1 over 0.866, which is approximately 6.928.
You then repeat this method every time you figure out the perimeter of the new inscribed polygon. Keeping in mind that you have to recalculate your scale factor every time you add more sides to your polygons because the distance from the center of the polygon to the midpoint of one of the sides gets greater each time.
By using these methods, Archimedes was able to figure out that pi was in between 3 and 10 over 71, or approximately 3.1408, and 3 and 1/7, or approximately 3.1429.